Hello everyone, welcome back. In this particular video, we're going to start a discussion on carbonyl compounds. So the next series of videos would be on the reactivity of carbonyl compounds. So we'll look at the synthesis and the reactions of carbonyl compounds. Now, carbonyl compounds include aldehydes and ketones. And these compounds, recollect, they contain a carbon double bonded to an oxygen as the functional group. So that's the functional group in these compounds. Okay, the C double bond O. So that's the functional group in these compounds. So in this particular video, we're going to start off by summarizing the syntheses of aldehydes and ketones. This is mostly a review of reactions that we are already aware of. Okay, so aldehydes and ketones, or carbonyl compounds in general, they can be synthesized from alcohols. That's one way of synthesizing these. So for example, primary alcohols, these can be converted into aldehydes and primary alcohols can be oxidized into aldehydes. Now, there are various oxidants that can be used for achieving this reaction. So we could use PCC, pyridinium chlorochromate, or we could use DMP, or even a Swan oxidation. I've identified two oxidizing agents that are capable or facilitate the oxidation of primary alcohols selectively to an aldehyde product. Similarly, secondary alcohols are oxidized into ketones under similar conditions. So secondary alcohols go into ketones, and we can use PCC, or you can use DMP, or in this particular case, even chromic acid is applicable because ketones cannot be further oxidized. The issue with primary aldehydes is they would undergo a complete oxidation to carboxylic acid if we use chromic acid. So alcohols are one set of starting materials that can be used for synthesizing carbonyl compounds. Similarly, carbonyl compounds can be synthesized from alkenes. From alcohols, let me write this down. So these are oxidation reactions. From alkenes, we can synthesize carbonyl compounds using ozonolysis. Ozonolysis of alkenes affords or gives carbonyl compounds as products. So, for example, if we use a di-substituted alkene, this will undergo ozonolysis followed by a quenching with dimethyl sulfide, and recollect that it will cleave the double bond and add an oxygen to both of those carbon atoms. So what we get as products are two molecules of the aldehyde. Now, it really depends on what these R groups are, okay? And this is a di-substituted alkene that we've used here. So there are two hydrogens there. That's why we are getting an aldehyde as a product. Contrast that to an example where we use a tri-substituted alkene, let's say. We do an ozonolysis on this. This will give us carbonyl compounds again, but our products are going to be a ketone and an aldehyde. Okay, so this half of the alkene becomes a ketone, and then the other half becomes an aldehyde because it's a tri-substituted alkene. if we start with a tetra-substituted alkene, that means there are 4 R groups around that alkene, then we would get 2 ketones as products here. So it really depends on our starting material. So depending on the substitution on the alkene, we will get various carbonyl compounds as we do this reaction. Again, it's not a complete list. I've sort of exemplified some scenarios here. Finally, carbonyl compounds, aldehydes and ketones, these can also be made from alkynes. This is through the hydration reaction. So a hydration of a terminal alkyne. We do a hydration on a terminal alkyne. And this sometimes involves the use of mercuric sulfate with sulfuric acid. When you do a hydration on a terminal alkyne, you get a ketone as your product. So that would give you a ketone. On the other hand, a hydroboration oxidation of a terminal alkyne. So if we start with a terminal alkyne and we do a hydroboration oxidation, okay, that's a 2-step process. We will get an aldehyde as our final product, okay? So this basically is a summary of all the methods that we know so far or thus far for synthesizing carbonyl compounds, aldehydes and ketones. Now, whether the product is an aldehyde or a ketone sometimes depends on the starting material. So if you're trying to make an aldehyde from an alcohol, then the alcohol must be primary. If you're trying to make a ketone from an alcohol, the alcohol must be secondary. Other cases, it depends on the choice of the reagent. So from the same alkyne, terminal alkyne, we can convert it into a ketone or an aldehyde by the choice of a reagent. A hydration reaction gives us a ketone as the product. A hydroboration reaction gives us an aldehyde as a product. So I hope everyone finds this helpful. Please stay tuned. We will be looking at more reactions of aldehydes and ketones or carbonyl compounds in general in the next series of videos. Bye.